In this video, we will continue on the beginner's guide to SDL2 in the fourth language, specifically G4. So if you're just starting out with this video, you'll need to go to github.com, Programming Rainbow, Beginner's Guide to SDL2 in G4. You want to clone that repository, and this is the fifth video, so you want to grab the source code that we ended off with in the fourth video, which you can find in the video 4 folder, and it's called main.fs, and you can copy that source file into the top level directory, and you'll be where we left off with in the last video. Okay, let me just show you what that looked like real quick. Okay, so G4 main.fs, and right now we have this window that's 800 by 600 opening. It has a black background. It has an image that we've loaded and displayed as the background. We can press spacebar and we can change the color to a random color. We have a title up here called Colors and Icon. And we have an icon that we loaded that I showed you in the last video already. So in this video, we will be loading up a new module called the TrueType font module. We'll be opening a TrueType font. We'll be creating text on the surface, converted it to a texture, and then moving it around the screen with the rectangle. So we're going to deal with colors, rectangles, all kinds of new stuff in this video. Okay, so the very first thing we need to do is we do need to initialize the TTF module. So that is right here. It's called TTF init. And this one takes no flags, but it does return 0 on success or -1 on failure. And the reverse to this is TTF quit. So let's get started with these two. And we also need to remember to require the TTF fourth module here. So this one's going to be require SDL2. So it'll be SDL_TTF.fs. And that's going to give us access to everything that would be in the SDL TTF module. So we're going to go down to initialize SDL. And this is where we're initializing SDL here. And then we're initializing the image module. So right below that, we don't need anything on the stack for this one because it has no parameters that we're passing in. So we just need to call the actual initialize fourth word. Okay, but it does leave a 0 if it's successful or something else if it's not. So we can just use we can use the if word directly to check this, because if it's 0, it's just going to pass by the if. But if it's not 0, something went wrong. So we'll just put the if here, and then we know how to deal with shutting down now. We just create an error message, and then we call error. So initializing SDL _, and this will be TTF. And I did forget the colon. I'm going to put it up here as well. There should be a colon space, just to make it look nicer if the error does occur. Okay, and then we put the then on that. So it's very simple for this one because there is no flags that we're passing in. So just simply we're calling the word, and then we're checking what's left on the stack, that's 0, if it's a 0 or not a 0. And the way that we shut it down is with a TTF quit. So we're going to do it in reverse order. Since it's the last thing we started up, it's the first thing that we're going to shut down. Okay, so that deals with giving us access to the module, and then bringing that module online, and then shutting that module down. Now I'm just going to run the program real quick. It's not going to do anything. I just want to make sure I haven't made any errors or typos or anything else, because I don't actually have a fourth LSP running. The only thing I have going on here is syntax highlighting through tree sitter. So yeah, that's what I am using tree sitter for syntax highlighting. VS Code, you probably will also get some kind of basic syntax highlighting. That's why in the very first video, I had to make sure that it was being seen as a fourth file type. And we can check that real quick with echo. And I think it's ampersand file type. And it says it's fourth, so it should automatically do that. But if you watch my first video when I created the new file, it didn't automatically see it as a fourth file, so then I wasn't getting any syntax highlighting. So if I do make mistakes, it's only really showed me like syntax highlighting. It's not an actual LSP, so it is good to just test your code every once in a while, make sure that you haven't made a mistake. So it still looks good. So nothing obvious. Okay, so the very next thing we're going to do, we've initialized the TTF, we've shut it down. So now we need to actually create a font. So this is a font object that's on the heap. That's a SDL, or it's a TTF font, a pointer to a TTF font. So it's something we're managing on the heap. And we need a string to the actual TTF font that we're going to use, and I'll show it to you. And then we need a size, and this is a point size, not a pixel size. But we're going to use 80, and I'm going to make a constant to hold that. So we'll call this word, we'll put these two things on the stack before we call the word, and then what's left on the stack will be the address to this TTF font. And just like textures that we loaded, or the render or the window, the way that we see if this failed or not is if we have a real address, it succeeded, and if we have null or 0, where the address should be on the stack, then we failed. So that's we've kind of seen the same style thing over and over again. Right here, we're creating the constants. I'm just going to add a new one for our font size, which I'm going to put as 80. I'm going to call it text size or font size. I'll just call it text size. It doesn't matter. Okay, so that's creating our text size. But we also need we're also going to have this pointer, just like we have with the background. We're going to end up with an actual texture, but before we end up with a texture, we're also going to have a font. So I could just have this on the stack and get rid of it after I make my text, but I'm just going to save it for simplicity. So I'm going to create a new value in a word, or however you want to call what this is. It's not a variable technically, but I'm going to create a new one of these. So it's null again. I'm putting the null value in a new word called, and we'll call this text font. And the reason why I'm doing this under, and this is it from me from doing other languages. When I usually do constants, like in C or another language, I would make it all capitalized. So you don't have to do this. And down here, this is not a constant. So when it's things like preprocessor directives, constants, things like that from like the C language, they're constants. And since SDL is already doing that here, that's why my text underscore size is capitalized here and down here. But this is not a fourth thing specifically, so you don't have to follow these conventions or anything. It's just, I don't know what the fourth convention is. I don't think it has one for this, so I'm just using what is comfortable with, what I'm comfortable with doing. Since this is acting more like a variable here, I'm just using a normal name. And up here, I'm using the capitalization with also snake case. Okay, so we have this. This is going to be capturing our pointer right here. So what we need to do is, I'm going to do this down in load media, and we're going to create a new font. So again, we're using this word right here, and we need a C style string, and we need the point size that we've already created constant for, and we're going to be returning this. In other languages, I put this all in load media, but in this specific fourth one, I actually broke it out into its own word definition, so we can do that. So down below random, I'm just going to make, because it's a little bit complicated to get the text up and running, so I ended up breaking it out into its own word. So we'll just call this create text. And this is going to take nothing off the stack and put nothing on the stack. Okay, so the first thing we need is, we need two things on the stack to call this TTF open font word. The first thing we need is a C style string, and the next thing we need is the point size. So the string is the relative path to where this font is. So up here in this fonts folder, I have free sans bold TTF. This is the TTF font that's used by default by like Pygame 0 and Pygames, stuff like that. But I just use it in all my projects. It's just a basic generic true type font to use. So it's relative to this file right here. So it's in the fonts folder and it's called Free Sans Bold TTF. So that's what we need to use. So I'm going to go with the fourth way to make a C style string, which is I'm going to use the escape, the string escape, the string version that has the escape ability, the escape keys ability. So it's going to be fonts and then free sans bold.ttf. And then we need to add in the null character with the escape key, escape sequence, or however you want to say it. And then I know this is going to put the address to the character address to F on the stack, but it's also going to put a length. So I need to drop that. I need to drop the length because I just need the address to F with the null terminated for a C style string. Okay, and the next thing we need is the size that we created above the constant. So this text size. Okay, so that's on the stack, and now we can just call our word ttf open font. And remember, it's leaving on the stack when this is done. It's leaving either null or an address to a TTF font. So we're gonna take that whatever's left on the stack here, and we're gonna put that to text font, what we made above here. Where is it? Right here, text font. So it was null, but now we're moving into the value of whatever was left on the stack. So this could be 0, or it could be an address. So we need to check that. Just like what we did with any of these right here. Same idea. I'm just going to yank this right here and reuse it. Okay, except we are not checking background, we're checking text font. Okay. It's basically, we're checking if it's 0. If it's 0, something went wrong. If it's not 0, everything's great. And we'll say error opening font. Okay, so that gives us our font. Now, the next thing that we need to do here, well, we need to close the font. So this is just like destroying the texture. So this is a heap allocated, this font, SDL allocated on the heap, this space. So we need to manage it, right? Just like we did with textures or the window or the render, we need to destroy them. So to destroy a font, it's actually called close font. So it just needs the pointer to the font on the stack, and then we call this word ttf close font, and then nothing is put on the stack from this. It's not returning anything back to the stack. Okay, so this is quite simple. So we're going to put this up in the game cleanup right here, and I'm going to put it with these. These are all managing. These are all removing memory that was put on the heap. So that's why these are together. These are modules, and these are all the kind of managed memory items that we need. So this one is the text font, and it's TTF close font. Close font. And then I also want to put null back into this TTF font so that we don't have text font still holding on to an address that is no longer allocated. Okay, so just like the rest right here, these are all kind of equivalent things that's going on. So this one is cleaning up the font and then setting it to null. This one is destroying the texture, setting that to null. Same idea. And it's in reverse order, so these are on top. Okay, so now that we have closed the font, now let's do something with the font. So we have this font and we can create a surface. We can't create a texture directly. That's what we really want is a texture, but we can create a surface, which is not hardware accelerated. But we can put text onto the surface. So the things that we need here is we need the font, a pointer to a font, which we have. we need a string, a C style string, which we can create, and then we need a color. And I did discuss this in the very first video, but this one doesn't take a pointer to a font. It takes a font, and this is not going to work in Forth. At least my limited understanding of Forth, I can't do this. So what I have done when I made the bindings for gforth is that I made a wrapper function that has a different name, but then the gforth word that it calls that wrapper function is this exact same name again. So you see the same name, but what happens is it's receiving the color as a pointer, and then it's dereferencing that pointer and sending it off to SDL. So for us, we are going to be sending a pointer. So this is going to be a pointer to a color, not the color directly, because I just don't know how to do that. I don't know if it's possible. So any of these kind of things like this that you see where it's receiving this struct, this SDL color as a struct. When we see this directly, here's the color right here. Anytime we're seeing this and it's being passed in directly, just understand that for gforth bindings, we are passing it in as a pointer, not directly, because we can't do that directly. Okay, so we need our font, we need a C style string, and we need a color. So since we need a color, let's deal with making the color first. I'm going to create I guess it's a variable that I'm allotting to. I'm going to allot the space to this, and it's going to give me a pointer basically. For Forth, it's called a variable, but it's an address. It's giving me an address. So up here where we're kind of making our pointer stuff or our variables right here, what we want to allot on the in memory. We need enough size for this SDL color. We want to allot the memory that we're going to use as a struct. But for Forth, it doesn't care. It just says how much memory do you want. We're going to do that. So just like what we did up here, this is also allotting memory. Even though this is a union, it's holding structs. Forth doesn't care. We're going to go create, and this one we'll call text color. Okay, so we've created this text color, but we need to allot a certain amount of space, and the amount of space that we need to allot is actually, we just use SDL color. That actually for Forth is the size of what this is, and then we'll use allot. So we're doing the same thing up above. Basically, we're allotting the amount of space that we need, which is going to be, it's going to be 4 32-bit ints. Or sorry, no, it's going to be 4 uint8s. Later on, the rectangle will be 32-bit ints. This one is going to be 4 unsigned 8-bit. Yeah, these are all uint8s. So it's actually going to be allocating 4 bytes for us. Okay, so that creates that. And then down here, back in this create, right here, I'm just going to put the semicolon so I don't forget about it later, closing this off. But here we want to kind of set up this color, and I want this color to be white. You can choose other colors. So I'm just going to throw onto the stack the address to this. So this is the address. Well, let's see if I can just show you what I'm talking about. CD, yeah. So oops, that's not what I want to do. Sorry. I want to just open up gforth, and let's require. So when I do this, say create, we'll say test color, and then I go SDL color allot. I got nothing on the stack. Okay, let's just show you what SDL color is. So this would be a type in C, but in Forth, what we really need is we need the size of it. And we see that it's of size 4. It's 4 bytes. And if we put a test color on, I'll just pop that off the stack. If we'll put test color on, this is an address, okay? Now we can get one of the, we can pull from test color, right? But if we just did that, so this is still on the stack, and if we were to say, now this is 4 bytes, so this is going to be not correct, but just to show you, if I were to do L, this is not correct. I'm just telling you, but I'm just doing this. It actually says 0. Okay. But what we need to think about, this thing is a color. This is 4 uint 8. So we actually don't need to pull a the L fetching. We're not fetching with L, which is 32 bits. We need to fetch with C, which is 8 bits. And it is unsigned, so that'll still work. So if I want to actually put some values in it so I can kind of show you what's going on. So I don't think anything, yeah. So I'm going to pop this off, and I'm going to put the test color back on. Okay, and what I want to do is I want to set each of the colors to something. I'm going to set them to like 1, 2, 3, 4, 5, or so you know it makes sense. Okay, so it's on the stack, and I'm gonna dupe it. Okay, sorry I'm not using capital letters, but so we got these 2 addresses on the stack. Well, the top one I want to change it, right? I want the offset to the red color. So I'm going to use this SDL color, and then I'm going to go minus. So remember, this would be equivalent to in C if I had the test color dot R or dot red or green or blue or alpha, okay? But we can't do it that way. The fourth way, we need the address, which is already here, and then we use the SDL color, and we do a tac, say red, okay? And that's going to modify this address that's on the stack. So this is the original address, and this is the new address. And what's going to happen is this is actually not going to do anything because red is the first. Let me show you. Red is the first one. So the address to the color and the address to red member of the color is actually the same address, but the address to green is different. It's an offset. So I'm going to do this real quick, and we should still see the addresses the same. There should still be 2 addresses that are the same. Okay, but now let's do blue, red, green. Sorry, green. Now the stack is going to look different. Look, it incremented it by 1 because the green is the next byte. And now I don't want to use a different one because this address here is not the original address anymore. So I'm going to pop that address off the stack and reduplicate. So we have the original addresses again. And now let's do a red, green, blue. And it's going to be in that 8 is going to be incremented twice. See? And I'll do the same. Oops. I didn't type dupe all the way. So so if we did alpha, which is the very last thing, it's going to be added 3 to it, basically. So we got 8, 9, 0, 1. Okay? So they're just offsets. They're taking the address and they're offsetting. I hope I'm explaining this. But basically in memory, if you're in C or any other language, if you have a struct, like especially C and C++, if you have a struct, that's just a memory address. The members are just offset. So all we're doing here in fourth is, again, we have the address and we're just offsetting it. And then we're saying, hey, pull that from there. But I want to show you something. The reason why I came into this, let's set some values here. So I'm going to pop the first one. Okay, wrong thing. So So I can set the first item by just putting a value in it. So let's put 1 in it. And then I'm not even going to use an offset because I know the address to test color is actually the same as the address to the first item. So I'm going to do a C store. Okay. Oh, okay. Well, I guess I can't. Oh, I had them backwards. Sorry, I needed to swap the address. Let's try again. So if I were to put the number on first that I want to store, then the address, then C. Okay. Now the next one, what I need to do is this is fine for red, but for green, I actually need the SDL color. This will work for green, but I want to store a different number. So let's store 2 there. And then blue, let's store 3. And then for alpha, let's store 4. Okay. So now let's just check one of them. We can say, we could do a fetch for alpha. And we'll just print that out. It's 4. I should have printed it the other way. Okay. So we know it's 4. And if we check red, it's 1. That's good. But what if we don't tell it to pull one, specific? What if I just did this? What if I did this? This will totally work, but I'm going to get some crazy number that's not going to be the right thing. See? So what's happening is this is pulling. Imagine, I have in the stack I have 0, 0, 0. Let's see. There's 8 of them. It says 1, 2, 3, 4, 5, 6, 7, 8. So this is what is in the memory at the address. And then the next one is a 2, right? So this is 1, 2, 3, 4, 5, 6, 7. That's what's in the memory. Okay, so this is what is actually happening. I set the first one to 1, the second one to 2, the third one to 3, and the fourth one to 4. So this is red, green, blue, alpha. So when I do an L fetch, I'm actually fetching the entire thing like this. And it's going to give me the equivalent of that number, which is this number. It doesn't know what I'm talking about. Okay, so you need to be very careful when working with these to be fetching the correct size and the correct sign. Like if these are unsigned, but if they were signed, I would need to make sure I'm doing a signed fetch. And when you're storing things, if you don't store as C, right? If you don't store as C, if I were to do a store as L, it would be totally messed up. The representation here would not be right. Let's try that real quick. So I'm going to do a store on, and I'm going to do it on the red channel. So I'm just going to store 1. So I'm doing it to the red channel, but I'm going to store with the L. See, green should be 2. Blue should be 3. And alpha should be 4. So it's messed up. I basically told it to store information, but it's overriding a bunch of other things. So with this, I have this chunk of memory, but I need to make sure I'm choosing the offset, and I need to make sure that I'm storing and fetching the correct size. So this thing is 32 bits in size that I've created, but I'm actually dealing with it in 8-bit increments, 4 8-bit increments. So I know that's quite long-winded, but basically if you start storing the wrong thing or fetching the wrong way, you're going to get very funny information out of this. But if you know what you're doing, you can completely, do everything that structs can do. So I know that was long-winded. I got sidetracked. Okay, so these colors they're 8-bit unsigned ints that goes from 0 to 255. We've already seen colors before, red, green, blue, alpha. So one thing I would leave the alpha at 255. Otherwise, you're going to get some transparency going on. You'll kind of start seeing through the text to what's underneath it, which would be the background image. And you might want that, but for this purposes of this, I do not want that. And then you can create whatever color you want, but I'm going to use white. So I'm going to use 255 on all of these. So what I'm going to do is I'm going to throw onto the stack the memory address of the color. Okay, so that's on the stack. And now I'm going to do this 255. And I need the number first on the stack and then the address. So I'm going to do an over. So what's on the stack right now is the address, this number, and this address got duplicated to the top of the stack. So it's address, number, address. Okay? That just means I'm holding on to the original address after this operation's done. And we're going to do the offset, SDL color R. And we are storing it with C because C is 1 byte. It's a character. Okay? So this right here, this store operation has taken the number and the address. The original address is still on the stack now. So we can do it again. We can go 255 and we can say over again, so I can again duplicate that address. Otherwise you need a swap. So we'll do green and I'll do C store. And again, 255 over SDL and color. Okay, now for the last one, I just want to consume that address. I don't want to actually duplicate it again. So this time I'll do a swap. I'll say 255 swap SDL color. And if you ever get confused on what's on the stack, which I do quite a lot, it's you have to kind of visualize what's happening in your head, but it might not always be exactly. So I'll end up and I'll be writing my code and testing it, and I'll start doing this. I'll start going S CR, and then after this I'll do another S CR, just to be able to visually see what's happening. The CR is a carriage return, so it's not typing it on the same line. Okay, so I should see this address on the stack, and then I should see the address again, the address again, the address again, and then the address should be gone. Okay, so let's try this real quick and see what the output is. Because like I said, with this stack-based thing and putting things on the stack and pulling things off the stack, sometimes it really helps to visualize what's happening with the stack. Okay, we didn't see anything, and that actually tells me that we're not calling this piece of code. So this create text, we actually didn't call it down here. Just check the order of it. Yeah, it's after load media. Oops. Okay, so there we go. I was expecting an address, an address, an address, an address, and then nothing. And that's what we got. So, but that is very helpful kind of technique to be able to see, because the address is here because I put text color, so that address is on the stack now. So don't be afraid to kind of constantly be checking what's on the stack and what's not. I do it constantly, so I know what's going on with, you know, if I'm, sometimes things might be leaving something on the stack that you didn't know about, and then you start just filling up the stack with unnecessary, and a loop is not going to be good. So we've set our color to white and it's opaque. The next thing that we need to do is we can actually make text now from, you know, we can use this word now, the TTF render text blend. And the reason why I'm using the blend version is so it deals with the aliasing. So it's like an anti-aliasing around the letters. So they're kind of nice, smooth, and there are no jagged pixels. Okay, so we need a font, which we have. We need a C style text, which we can create, and we need a color, which we have now. Okay, so we'll throw those on the stack, and then we'll call this word right here. Just going to copy this. So the first thing that we need on the stack is the pointer to the font. I think that's right? Pointer, yeah, pointer to font, text, and then color. So to put the pointer to the font, we just call it text font. There, that's the pointer. And now for the string, backslash. This gives us our escape sequence so that we can make a C style string. And I'm just going to put SDL here. And always make sure that there is a space here, because these three are actually a word. And I need the escape sequence for the null character. And I also need to drop the length. Okay. And the next thing we need is, I know it in the C version, it's not a pointer, it's using the color directly, but we are using a pointer. And that is just going to be text color, which is a pointer. If we just type that in, that gives us the pointer on the stack. And now the actual word. Okay, and what this is going to return is a pointer to a surface. Now, I didn't save the surface, so if I did have a word set up above to save it in, I could say to surface or something, right? Whatever I called it. Would be text surf, something like that. But I didn't do that. It doesn't exist. And actually, we're not going to hold on to the surface. We're just going to use it and get rid of it. But I do need to find out if the address is good or not. So what I'm going to do, I'm going to duplicate it and then check it. Because if I check the address, then I consumed it and I lost it off the stack. So I need to duplicate it first. So we're basically doing the, this check right here. It's just we were putting it in a named variable before, and now it's just hanging out on the stack. So I could just do this like this. Right down here. It doesn't matter. It doesn't matter if it's inline or not. And I'm just going to take this error here. So we'll say error creating text surface. So this is taking our font, taking our string, taking our color, and putting it all together to make a surface. And so that address to this surface is on the stack. So we've duplicated it so we can check it to make sure it's not 0. And then now we still have that address on the stack. And what we really want to do is we want to convert this to a texture. So we have an SDL. This is not part of TTF. This is part of the normal SDL module. But it's create texture from surface. And this is quite simple. We just need to put the address to the renderer on the stack, and then the surface on the stack. The address to the surface. Okay, and it's going to return a texture. So this one, we do want to capture this texture. So I am going to create a variable up here, or a named word, however we want to call it, for the texture. We'll call it text image. Okay, so we have this. What we have on the stack right now is our surface pointer. We have a pointer to the surface sitting on the stack right now. And what we need is we need a render and the surface pointer, and then to use our word. So I'm going to put the render. Okay. And then I do want to keep this pointer on the stack for this surface. So I'm going to do an over, because we still need to free the surface later on. So that's going to give us a surface pointer, a render, and the surface pointer again. And then I'm going to call this word right here that creates the texture. And now we can, that's going to put the address to the texture on the stack. And we want to move that into the texture image. Or the text image. Okay. And then before we do anything else, we're going to finally free this surface. It doesn't matter if this fails or not. We've already used the surface the last time that we need to use it. So right away, I'm going to free the surface, and we already know how to do that. We call SDL free surface. Okay, so that's already on the stack. So that's now been consumed. Now the next thing I want to do is test this text image to make sure that it is correct. So I'm going to do this right here. I'm just going to yank that. And I'm going to change this to text image. So this is testing whether this pointer is good or not again. And we will say error creating texture from surface. Okay, so now we have finally a texture. Okay, now I did skip a step here. What I didn't do is I didn't make a rectangle. Okay, so this is an 80 size font, text with 80 size font. And if I go to stretch, now this is going to be stretched to take up the whole screen. And the problem with this is it's actually going to look quite ugly and pixelated. That's because I've created an image of a smaller text and I've stretched it. So it's not the fault of the TrueType font. It's actually the fault that I've created a texture and then stretched it. And we'll kind of see that in a second. And then we'll make a rectangle and we'll continue on. But I just want to show it. So if we go down here, we could do the exact same thing that we do with the background. We need to put the render on the stack, and then we need the image, which is our text image. And I'm going to use the null for both of them. So we're using this entire source rectangle and the entire destination rectangle, the entire one. That's what I meant. And I'm dropping this again. If we don't drop this, the stack starts filling up every 60 times a second. This thing is, kicking out 60 zeros. I'll show that to you in a second as well. Okay, so this is the ugly text. And again, this is not the fault of the TrueType font at all. This is my fault, and I will show it. And before I go any further, I'm going to remove this drop right here. And then I'm going to print the I'm going to print the stack. Okay? And we're going to see the stack start filling up. You see, it's getting bigger. Look at this number. This is how many items are on the stack. It's only showing like 8 zeros, but there's actually 400, 500. And at some point, this is just going to overflow. Okay? So that's why you kind of want to check when you're programming what the stack is doing. So if we drop that, we try it again. And now our stack is, there's nothing on it. It doesn't actually matter if there's something on the stack when we check it. It doesn't need to be 0. Something could be on the stack, as long as it's not growing or shrinking. If that thing was on the stack for it's being used later on in the code or something, it needs to be there. That's totally fine, as long as it's kind of it's doing the same thing every frame. Okay, so let's talk about the rectangle. Okay, so this is a surface, and the only thing I really want to show you from this is that it contains two members. It's got a width member and a height member. And this is really good because we want to use a rectangle, and we want to populate that rectangle with the width and the height, because we're going to use that as a destination rectangle. So right now what's happening is our width could be something like 100 or 160 or something. So say our height, I'm just making up numbers, but let's say our height of our SDL text is 100 and our width is 160, okay? So when we go to display it, we say, yes, we want the full source. That's 160 by 100. We want to use that whole 160 by 100. But then when we display it to the render, we say, well, we're going to use our whole render. So now it's going to stretch that image to 800 wide by 600 tall. So what we really need is we need to know that 160 by 100. We need that. And if we put that in a rectangle, and then when we say to display it on the render, we say, no, we don't want to use the entire width and height of the render. We want to use 160 by 100 tall. And oh yeah, we can put it at X0 and Y0 for the top left-hand corner, the origin of the image where it's going to be. So we need to hold this in an SDL rect. And an SDL rect is just another C struct, and this one is 32-bit ints. So this is 4 32-bit, and these are signed ints. That means we need to be careful when we're fetching from this, because we need to do a 32-bit signed fetch, not a 32-bit fetch, but a signed fetch, because the topmost bit is the signed bit. And if you just pull it as an unsigned fetch, -1 will turn into something like 4.3 billion. You'll get the completely wrong number because it's not dealing with the signed bit correctly. Okay, so we are going to create this rect, and it's going to be very easy because the surface already has the information we want. And since we've started with the surface, we can just grab that information from the surface. And this is the way we do that. So before we kind of create the render, or before we create the texture here, remember the surface is sitting on the stack right now, the address to the surface, right? So if I also add a rectangle that we didn't create yet, sorry. So up here, let's create a rectangle first. So we go and create, and we'll call this text rect, and it's an SDL rect. That's going to give us the size to a lot. Okay. So that'll give us a pointer to a rectangle. So down here, we're going to throw the address of that rectangle on the stack. So we got text rect on the stack. And remember, the surface is already on the stack. So what I'm going to do is I'm going to over, so that I'm now having the rect surface and the SDL surface is on top of it. Okay. So basically it's duplicating the surface one and putting it on the top of the stack. So, but what I want is I want the member of the SDL surface that is the width member. Okay. So this is going to be SDL surface, and it's going to be -W. So again, if this was in C, it would be .w to get the member. But because it's fourth, it's the address of this, and then we use the kind of the type -W to get, to offset the address. And now this is a signed, this is a 32-bit signed bit. So we need to do SL fetch. And that's going to make sure our number is correct. Like I said, if you had a -1 in there and you did an L fetch, it would give you 4.3 billion. But if you do an SL fetch, you're going to get that correct -1 back. Okay, so this is putting the value on the stack of this. And now we're going to over this is going to actually now duplicate the rect address, because that's the second item down on the stack. It's going to duplicate that on the top. This is where you probably want to print out the stack as you're figuring this out. So now I'm going to index this. So rect.w. So this was the address of the rect now, and now this is offsetting it to the w member of the rect. Okay. And now I'm going to do a store, and the storing is not signed, so I can just do an S store. An L. There is no SL store. There's only L store. So it's definitely the fetch that you need to make sure if it's signed. If it's signed, it needs to be SL. If it's unsigned, it's L. It's fine. But the store is L no matter what. Okay. So I'm getting the width that is of the surface, and I'm storing it in this rectangle width. Okay. Now we still have the address to the surface and the address of the rect on the stack at this point. So I can do the exact same thing again that we did in this one. I can go over SDL, and I can't see. There we go. Why did I put free surface here? This is not supposed to be free surface. That wouldn't even work. It's SDL surface. Sorry about that. So this is going to be height. So basically I'm getting the height of the surface that's on the stack. And we're doing the signed 32-bit fetch. And now I'm bringing, sorry, I'm not going to use over this time. I'm going to use swap. Because over would duplicate the address of the rect, but I actually don't need access to this rect again. So instead of saying over to duplicate it and put it on top, I'm going to say swap to put it on the top. So it doesn't duplicate it, just puts it on the top, and I'm going to consume it the last time. Okay, and then we're going to do the same thing, the store. So I'm getting the width from the surface and storing it in the rect, and I'm getting the height from the surface and storing it in the height. So now my rectangle is populated with the width and the height. The x and the y are still going to be set to 0, but the width and the height are actually populated now. And so that, I know that's kind of overs and swaps and stuff. It might be helpful to do a CR. You could do it inside of the line too. I'm just showing it real quickly what's happening. Okay. So again, as you're building this up, you might actually do an over and then do an SCR there and then do it, you might do it over and over again just to visually see what's happening with the stack. Okay, so we have this rectangle now. So let's use this rectangle to draw it correctly. Now, the rectangle has 4 members. It has an x, a y, a width, and a height. We populated the width and the height, but the x and y are set to 0. And what it's going to be is the top left-hand corner, the x and the y is going to control the top left-hand corner of your image that you're drawing, but that x and the y corresponds to where it's at on the render. So if I were to say 400 by 300, that would be the center of the screen. That would that would cause the top left-hand corner of my text to be directly in the center of the screen. Not the text directly in the center, the top left-hand corner of the direct. So the top left-hand corner is my origin. It's where I'm controlling the position of the text. But since it's at 0, that means the top left-hand corner of my text is going to be in the top left-hand corner of the screen. Okay? So right here, this is source rectangle, and the second one is destination rectangle, and that's the one that we want to use. And this one, this is already set up to take a pointer to a rect, which is fine. So we can just put it in directly. So text rect. Okay. So it's up here in the top left-hand corner, and it looks nicer now. Now I want to show you that the fact that it wasn't the size of the text that made it look ugly, it was the fact that it was stretched. So I'm going to change this from 80 to 320, so it's quite bigger text. And we'll see that it's because I stretched it, it's not because of the way it was. See that? It's quite nice, smooth-looking text. Okay, so let's change that back to 80. So we have this rectangle, and so what we can do is we can actually modify the X and Y position and have it move around the screen every frame. And that's what we're going to do now. So up here where the constants are, I want just a kind of a velocity for that my text is going to move at, but I'm actually going to have an X and a Y velocity that I'm going to be able to switch so it can change directions, but I'm just going to hold a constant that's actually just going to hold a velocity value. And I'm going to make it 3. And this is just going to be a constant, so this is not going to change. And I'll call it text vel for text velocity. But then down here, in these kind of mutable ones, the pointers and mutable values and stuff like that, I'm going to create a text x velocity and a text y velocity, but I'm going to set them to the constant that was above. So they're all going to be 3 initially. So I'm just going to put this on the stack. Oops. And then I'm going to store the value in text x velocity and the same for y velocity. Okay, so this is going to give us 2 mutable values here that are based on this constant value. Okay, and we're going to make another word, and it's going to be called text update or update text. It doesn't matter. Text create, and I think I put it in my notes as update text. So if it's update text, it should actually be create text too. But so this is going to take nothing from the stack, and it's going to leave nothing on the stack. And I'm going to finish it off here with a semicolon. And what we want to do is I want to actually increment the x by the x velocity. Okay? So we'll say text rect, that's the address in the stack, and then we'll get the offset to x. I'm going to duplicate it. And I'm going to, the reason why I'm duplicating is because I'm going to need this x address again later of the text rect. Okay, so now I'm going to fetch it, and I'm going to use SL because it's assigned. Okay, but I also want to, so I want to increment it. So I need the existing value that's in X. Then I need to increment that value, and then I need to store it back into X. So that's why I'm duplicating it. And then I'm pulling the value out. So I still have the address of the X member of rect. That address is still on the stack, but also the value of what was in that address is on the stack as well. And then I'm going to put the text xval, that is going to be actually 3 right now. So I'm putting that on the stack. So I got the original x value and I got the x velocity, and I'm going to add those together. Okay, so that's the whatever x is at the moment, which is 0, 3, plus them together, so that's going to be 3. I want to store it back. So this number is in the wrong order, so I need to swap it. And then I'm going to store it with L. Let's just try that real quick. This is not what my notes say because I'm duplicating and rotating things because I have more code after it, but I just want to see the text move. So hopefully that is good enough. Okay. And what also we have a problem with right here is we need to call this word, this update text, we need to call it here. So what I'm going to do, this is my game loop, and I'm getting events. I'm checking events that have happened, and then I'm drawing things. So between those two, I'm going to check events first, and then I'm going to change the game state. I'm going to update the game state. And this is called update text. So that's where I'm going to call that word. Okay, so now it's going to go right off the screen and keep going. So I could do this same thing. Let me, I'm curious if, yeah, it looks good. Okay. So if I wanted to do the Y, I could do the same thing. I could just yank this. And I would do text rect, and I would do Y. And then I would do the Y velocity. And that should take care of both the X and the Y. And I should be going from the top left to the bottom right of the screen. Okay? Now we need to think about how to check collisions with the sides. Okay, so I'm going to comment this out for right now. Let's see. There we go. So right here, I have this swap going on right here, but what I actually want to do is duplicate. What I need to do here, instead of swap, I want this, the new value as well. Yeah, I want the X address and the value. So I'm going to dupe it. So that's duplicating this number here, which is at the very first frame, it's 0, 3 plus. So I'm duplicating this 3. So the 3 is on there twice. But I'm also going to rotate because I need the address on top. And before I did a swap to get the address on top, but I actually still want that address there. And I couldn't do a swap right now because these two numbers are the same anyway. So what I'm going to do is I'm going to rotate. Rotate takes the third item and puts it on the top of the stack. So I'm still going to have this number. Okay, so the first thing we're going to do is I'm going to check to see if I'm moving to the left, remember the origin is the top left. So the origin of my image that I'm checking is the left side of the image. And I want to make sure if it's past the left of the screen. So the left of the screen is 0. So if it's gone under 0, I've penetrated the left-hand side of the screen. So I know we're not moving in the left direction, but it can be moving in the left direction. So I'm going to do that one first. And so I'm going to check the number that is up there, but I want to use the number again later. So I'm going to duplicate it. And I'm putting 0, and now I'm saying if this number is less than 0. The number that I'm duplicating, and I'm putting these are both on the stack, and I'm checking it. So imagine in math it would be like this, right? But this is reverse Polish notation or postfix, and so it's like this. And we're doing an if on it. So if it has penetrated the left-hand side, I want to make sure my text X velocity is +3. That would have been -3 for me to go this direction. So if it has gone this direction, I want to switch it to positive. So we have text. I'm going to use the constant. and I move the value of this constant to text x velocity, okay? So it would have been a negative number in this x velocity to get us going this way. And when I've gone down to 0, I'm going to change it to a positive velocity, which is 3. Okay, so we'll put it then on that. Now we need to check the other direction. So I have this, the text, and if this text is 160, well, the left side of it could be 3 or whatever the number is. But to get to the right side, I need to say, well, the left side is 3 plus the right side is 160. So my right side is actually at 163. So I need to add the width to find out what's the right side. So we'll say text rect, and we'll do the SDL rect W. Okay, so we're going to be getting the width now. And we need to fetch it with the signed 32-bit fetch. And we're going to add them because remember, I already have the number on the stack. We duplicated it up here and then we duplicated it again. The number is still on the stack. So I have this number, which is my left side, plus this is giving me the width, and I'm adding them together. Okay. And now since those numbers are added together, that's the right side. Now I need to check if the right side has actually bigger than the screen width itself. So I'm going to put screen width on the stack. I think I called it window width. Yeah, window width. So window width, and then in my notes, it's screen width. So depending on what version is on the server, just look up here. Whatever is up here, if it's window width or screen width, use the correct version. You know, depending on what you pull from GitHub. So, okay. So basically, so I had the left side and the width, add them together. Now I have the right side, and I have the window width. And if the right side is bigger than window width, then we need to switch the direction again. Okay, so this time we need it to be moving in a negative direction. So I'm going to throw the constant on the. I'm going to throw that on there, but then I'm going to negate it. And then I'm going to store that in the text x velocity. Okay, I will put it then on here. Okay, let's see what that does. I've disabled the Y, so we should be moving back and forth left to right. Okay, hopefully it's going to bounce off the right-hand side this time. Oh, that's nice. And hopefully it bounces off the left. Okay, so that's exactly what we need on the Y as well. I'm just going to check the stack to make sure it's all good. We're not getting an underflow, but we could be adding stuff. Looks good. Oh, let me bounce off both sides. Okay, perfect. Okay, so I'm just going to this code right here. I'm just going to yank this and convert it to the Y version. So this is all the same still, and right here is Y velocity. And this is going to be height. This is going to be window height. This will be Y. Okay, and I got to re-enable this. Now we could disable this one. Well, no, I have to do it individually because I don't have an LSP there. It won't understand how to comment. Okay, we have a problem. Underflow. Okay. Oh, I know what I did here. So in the original one, remember we just did a swap, but then I did a dupe rotate. Okay, let's see if it bounces off the top. Okay, that's pretty good. So that is the text bouncing around the screen. Okay, so let's just walk through what we did. We have enabled required the SDL2 okay, and then we have brought it online with a TTF in it. It took no arguments on the stack, and it just returns whether it failed or not. And then we shut it down with TTF quit. And the next thing we need to do is open a font. It's all in this create text. So we have this string that we're putting on the stack. We're making sure it's a C-style string with a null terminator. We have the size that we have up here in a constant right here, this 80 constant text size. Okay, and then we're calling the TTF open font word, and then we're moving what's left on the stack, the address or the null, we're moving that into text font, and then we're putting text font back on the stack and checking to make sure that it is not 0 or null, and cleaning up if it is. The next thing that we are dealing with is this color. So we are actually allocating this on the stack or heap. I'm not sure where it's allocating it, to be honest. It's allocating it. So this text color, and it's allocating the size of SDL color. And then we are using the character store. This is an unsigned store. Well, it doesn't matter. It's a store for 1 byte. And we're putting 255 into all of them. If you want different colors, you can mess around with the RGB. You're going to pick values between 0 and 255. But you want to leave alpha channel set to opaque. So that's setting all the colors. So we have a white text. And then we are going to make the render text blended. This is where we actually take our font and we take another C-style string, and then we have to drop it so it's a C string. And then we take our color as well, and we put all of them together to make a surface. Now, I didn't save the surface in one of the fourth words. It's not in the dictionary or anything. It's just sitting on the stack. So we duplicate it. We check to make sure it's good. Then we are populating our rect, and we're using the over to duplicate it, basically. But we're populating the rect width from the surface width and the rect height from the surface height. And we are actually freeing the surface down here when we get done using it. But the surface is still on the stack, so we're doing a render on the stack over with the surface again. And so we can convert that surface to a texture or create a new texture, from the surface, which we are storing in this text image right here, which is the text image here. And our text rect is here allocated as well. Once we have done that, we're freeing the surface immediately, and then we are putting the text image back on the stack to make sure that it is actually a real address to a SDL texture. Okay, and then we can go down here and we can actually draw it, but this time we're actually using the text rect to draw the rectangle. Okay. Now we have this new word, this update text. And what we're doing first is we're incrementing the x value by the x velocity, and that could be a positive or negative number. And then we're checking if the right side has gone less than 0. If it has, we're making sure that the text velocity is in a positive direction. The x velocity is in a positive direction. If we have taken our left side plus our width to get our right side, and that number is bigger than our screen width or our window width, then we need to be moving in a negative direction. So we're changing the text x velocity to the constant, but the negative version of it. So that'll be -3. Okay. And we're doing the exact same thing for the y. It's just you're using y and height and h, but it's all the exact same. And we're calling that in our loop, we're checking for events first, like quit events, key button, key press events. We're checking that. And then we're updating game state. And then we are drawing the game. So right here, we have this update text, which is that's updating right there. And that should be everything. So I hope you enjoyed that one, or I hope it was educational. And that is how you create true type font, make a surface, turn it into a texture, move it around the screen, and that's everything. So thanks again for watching, and goodbye.